Today's lesson is to choose an appropriate method for factoring a polynomial and then combine methods for factoring a polynomial. Recall that a polynomial is in its fully factored form when it is written as a product that cannot be factored further. Tell whether each expression is completely factored. If not, factor it. For a, 3x squared times in parentheses 6x minus 4, the 6x minus 4 can be further factored. You factor out 2, which is the greatest common factor of 6x and negative 4. When you factor out the 2, you're going to multiply it to what is already on the outside of the parentheses. So 3x squared times 2 would give us 6x squared on the outside of the parentheses, and then left over on the inside, once we divided out the 2, 3x minus 2. So 6x squared times in parentheses 3x minus 2 is completely factored. For b, x squared plus 1 times x minus 5, neither x squared plus 1 nor x minus 5 can be factored further. So x squared plus 1 times x minus 5 is completely factored. Here's an example for you to try. You're going to tell whether the polynomial is completely factored, and if not, factor it. For a, 5x squared times in parentheses x minus 1, neither 5x squared nor x minus 1 can be factored further, so 5x squared times in parentheses x minus 1 is completely factored. For b, 4x plus 4 times in parentheses x plus 1, 4x plus 4 can be further factored. You divide out the 4, factor out the 4, which is the greatest common factor of the 4x and the 4, and you get 4x times in parentheses x plus 1 times x plus 1. So 4 times x plus 1 squared is completely factored. To factor a polynomial completely, you may need to use more than one factoring method. Use the steps below to factor a polynomial completely. Step 1, check for the greatest common factor. Step 2, check for a pattern that fits the difference of two squares or a perfect square trinomial. Step 3, factor x squared plus bx plus c. Look for two numbers whose sum is b and whose product is c. Or to factor ax squared plus bx plus c, check factors of a and factors of c in the binomial factors. The sum of the products of the outer and inner term should be the b. Step 4, check for common factors. To factor 10x squared plus 48x plus 32 completely, and then we have to check our answer, we're going to factor out the greatest common factor first. That's step 1. So between 10x squared plus 48x plus 32, it's a 2. So we factor that out to the outside and we get 2 times in parentheses 5x squared plus 24x plus 16. Now we're going to factor the remaining trinomial left in the parentheses. So we factor it out and we end up with 5x plus 4 times x plus 4. To check our answer, we multiply the two binomials back together, and we still have the 2 on the outside of the parentheses, so we get 2 times in parentheses 5x squared plus 20x plus 4x plus 16. And then we multiply in the 2, and that gives us 10x squared plus 40x plus 8x plus 32, which is 10x squared plus 48x plus 32, which is the original problem, so we know we factored correctly. To factor 8x to the 6th y squared minus 18x squared y squared, we're going to pull out the greatest common factor, which would be a 2x squared y squared, leaving 4x to the 4th minus 9 in parentheses. That is the difference of two squares, a term being 2x squared and b term being 3. So we would end up with, outside the parentheses still, 2x squared y squared, and then we would factor out 4x to the 4th minus 9 into 2x squared minus 3, 2x squared plus 3. To check our answer, we're going to multiply the two binomials back together, and we get 2x squared y squared on the outside of the parentheses times 4x to the 4th minus 9 inside, and then we multiply the 2x squared y squared back into the parentheses, and we get 8x to the 6th y squared minus 18x squared y squared, which is the original problem, so we know we factored correctly. Factor each polynomial completely and then check your answer. 4x to the third plus 16x squared plus 16x. So here's an example for you to try, and then you can check back for your answer. First, you're going to factor out the greatest common factor. So that's 4x, which leaves x squared plus 4x plus 4 inside the parentheses. X squared plus 4x plus 4 is a perfect square trinomial. A term is x, b term is 2. So we factor it out. We have 4x still on the outside of the parentheses, and then we get x plus 2 squared on the inside. To check our answer, we multiply the binomial x plus 2 squared back out, so we would get 4x still on the outside, and then times x squared plus 2x plus 2x plus 4. And then we multiply in the 4x, and we get 4x to the third plus 16x squared plus 16x, which is the original problem, so we know we factored correctly. Factor each polynomial completely. Check your answer. 2x squared y minus 2y to the third. So here's an example for you to try, and then check back for your answer. So you're going to factor out the greatest common factor first, which is a 2y, and that will leave us with x squared minus y squared, and then that is a difference of 2 squares. So your a term is x and your b term would be y. So you would get 2y, that's what we factored out first, the greatest common factor, and then times x plus y times x minus y. To check your answer, you would multiply back together, and you would get 2y still on the outside of the parentheses, and then x squared plus xy minus y squared. And then you multiply in the 2y, and you get 2x squared y plus 2xy squared minus 2xy squared minus 2y to the third. And that leaves you with 2x squared y minus 2y to the third, which is the original polynomial, so you know you factor correctly. If none of the factoring methods work, the polynomial is said to be unfactorable. For a polynomial of the form ax squared plus bx plus c, if there are no numbers whose sum is b and whose product is a times c, then the polynomial is unfactorable. To factor 9x squared plus 3x minus 2, the greatest common factor is 1, and there is no pattern. It's not a perfect square trinomial. So a is 9 and c is negative 2. Outer plus inner would have to equal 3. So some factors of 9 would be if we chose 1 for the outer and 9 for the inner, and then factors of negative 2, 1 for the inner, negative 2 for the outer. We multiply the outer terms together that we chose, which were 1 and negative 2, and then we are going to add that to the inner terms we chose multiplied together, which are 9 and 1, and we would get 7, which does not work for this polynomial. Then let's say we chose for factors of 9, 3, and 3, 3 for outer, 3 for inner, and then for factors of negative 2, 1 for inner and negative 2 for outer. Multiply the outer terms, 3 times negative 2, and add it to the multiplying of the inner terms, 3 times 1, and you would get negative 3, which still doesn't work. If we chose the factors of 9 to be 3 for the outer and 3 for the inner, and factors of negative 2 to be negative 1 for the inner and 2 for the outer, then we would get 3 times 2 for the outer plus 3 times negative 1 for the inner, which is 3, and that's the numbers that we're looking for. So we write it as 3x and 3x as the first terms of our two binomials, and negative 1 and 2 as the second terms. Remember, we chose negative 1 and 3x to be the inner terms, so those go on the inside two number spots, and then 3x and positive 2 to be the outer terms, so those go on the edges of the two binomials. Factor each polynomial completely. We have 12b to the third plus 48b squared plus 48b. So we're going to pull out the greatest common factor, which is 12b. And then what we have left inside is b squared plus 4b plus 4, which is a perfect square trinomial. So we end up with 2 and 2. Remember to bring the 12b down, so we have 12b times in parentheses b plus 2 times b plus 2, or you could write it as b plus 2 squared. So 12b times b plus 2 squared. Factor each polynomial completely. 4y squared plus 12y minus 72. You're going to factor out the greatest common factor, which is a 4, leaving y squared plus 3y minus 18 inside. There are no patterns. It's not a perfect square trinomial, so we're simply looking for two numbers that when multiplied give us negative 18 and added give us 3. Some factors of negative 18 could be negative 1 and 18, but their sum is 17, which does not work. Or it could be negative 2 and 9, but their sum is 7, which does not work. Or it could be negative 3 and 6, and their sum is 3, which does work. So the factors needed are negative 3 and 6. We make sure that we bring down the 4 that we pulled out at the beginning, and we get 4 times in parentheses y minus 3 times in parentheses y plus 6. Factor each polynomial completely, x to the 4th minus x squared. Factor out the greatest common factor, which is an x squared, leaving us with x squared minus 1. That's a difference of 2 squares, so we get x squared still from the outside, and then we end up with x plus 1 times x minus 1. Factor each polynomial completely, 3x squared plus 7x plus 4. Here's one for you to try, and then you can check back for your answer. So there's no greatest common factor to pull out. We're just simply factoring. We need to find factors of 3, factors of 4, and then outer plus inner needs to equal 7. So we chose factors of 3 to be 3 for the outer, 1 for the inner, and then factors of 4, 1 for the inner, 4 for the outer. We would multiply our outer terms that we chose, 3 times 4, and then add it to the multiplying of our inner terms, 1 times 1, and that would give us 13, which does not work. If we chose 3 for the outer and 1 for the inner, and then 2 for the inner and 2 for the outer, we would get 3 times 2 plus 1 times 2, which is 8, which still does not work. For factors of 3, if we did 3 for the outer and 1 for the inner, and then 4 for the inner and 1 for the outer, we would get 3 times 1 plus 1 times 4, which is 7. Those are the ones that we need. So we write down 3x and 1x as our first terms in our binomials, and then 4 and 1 for our second terms. Remember that 4 and 1x are our inner terms, and then 3x and 1 are our outer terms. Factor each polynomial completely, 2p to the 5th plus 10p to the 4th minus 12p to the 3rd. Factor out our greatest common factor first, 2p to the 3rd, which would leave p squared plus 5p minus 6 inside. You check for a pattern. It's not a perfect square trinomial, so now you're simply looking for factors of negative 6 that add to be 5. So some factors of negative 6 could be negative 1 and 6, and when you add them together you get 5, and those are the numbers that work. So the factors needed are negative 1 and 6. We have to remember to keep the 2p to the 3rd on the outside, which is what we pulled out as our greatest common factor at the very beginning, and we get 2p to the 3rd times in parentheses p plus 6 times in parentheses p minus 1. Factor each polynomial completely. 9q to the 6th plus 30q to the 5th plus 24q to the 4th. So here's one for you to try on your own, and then you can check back for your answer. So you factor out the greatest common factor, which is 3q to the 4th, and you're left with 3q squared plus 10q plus 8, which does not follow perfect square trinomial pattern. So we have to find factors of 3, factors of 8, and outer plus inner should equal 10. So if we chose factors of 3 for the outer term to be 3 and the inner term to be 1, factors of 8, inner term to be 1, outer term to be 8, multiply our outer together, 3 times 8, and add it to the multiplying of our inner, 1 times 1, we would get 25, which does not work. If we chose 3 for our outer and 1 for our inner, and then 2 for our inner and 4 for our outer, we would get 3 times 4 plus 1 times 2, which is 14, which doesn't work. If we chose 3 for the outer and 1 for the inner, and then 4 for the inner and 2 for the outer, we would get 3 times 2 plus 1 times 4, which is 10, and those are the numbers that we're looking for. So we have 3q and 1q for our first terms in our binomials, and then 4 and 2 for the second terms. Inner terms were 4 and 1q, and outer terms were 3q and 2. And you have to remember to carry down the greatest common factor we pulled out at the beginning, which was 3q to the 4th. So your answer would be 3q to the 4th times 3q plus 4 times q plus 2. Factor each polynomial completely. 2x to the 4th plus 18. Here's one for you to try, and then you can check back for your answer. 2x to the 4th plus 18, we have to factor out the greatest common factor, which is a 2. So you get 2 times in parentheses x to the 4th plus 9. And x to the 4th plus 9 is the sum of squares, but that's not factorable. Remember, you can only do difference of squares. So 2 times x to the 4th plus 9 is completely factored. Just a review of the methods to factor polynomials. For any polynomial, you're going to first look for the greatest common factor. You're going to pull that to the outside. So for instance, if you had AB minus AC, their greatest common factor would be A. You pull it to the outside and you get A times in parentheses B minus C. In a number example, if you had 6x squared y plus 10xy squared, their greatest common factor would be 2xy. So when you pull that to the outside, you get 2xy times in parentheses 3x plus 5y. For binomials, you're going to look for a difference of two squares. So for instance, a squared minus b squared would factor into a plus b times a minus b. So in a number example, if you had x squared minus 9y squared, that's a difference of two squares, and you would get x plus 3y times x minus 3y. For trinomials, you look for perfect square trinomials and other factorable trinomials. So perfect square trinomial pattern would be a squared plus 2ab plus b squared, which factors into a plus b squared. And then you could also have a squared minus 2ab plus b squared, which would factor into a minus b squared. For the first one, if you had x squared plus 4x plus 4, that would factor into x plus 2 squared. And for the second one, x squared minus 2x plus 1 would factor into x minus 1 squared. For x squared plus bx plus c, you're looking for two numbers that when multiply give you the c term and add to give you the b term. So for instance, if you had x squared plus 3x plus 2, two numbers that when multiply give you 2, added give you 3. So it would be factored into x plus 1 times x plus 2. For ax squared plus bx plus c, you would factor it into products of c. So two numbers that when multiply give you c, a times c, and then added give you b. And then you have to chart it out so that the outer plus inner equals the b. And so 6x squared plus 7x plus 2 would factor into 2x plus 1 times 3x plus 2. For polynomials of 4 or more terms, you can factor by grouping. So if it was ax plus bx plus ay plus by, you could factor the first two terms together and then pull out their greatest common factor, which in this case was an x, so you'd get x times a plus b. And then in the second two, you would factor out their greatest common factor, which was a positive y, so you'd get plus y, and then it would be left with a plus b. There's the same thing in both sets of parentheses, so that's their greatest common factor. So you pull that out and you get a plus b, and then you multiply to what you would have left, which is just what's on the outside, x plus y. So x plus y times a plus b. So in a number example, if you had 2x to the third plus 4x squared plus x plus 2, and you grouped 2x to the third plus 4x squared, and then you grouped x plus 2, and pull out the 2x squared, and you get 2x squared, and then left in parentheses is x plus 2. For the second part, you would pull out a positive 1, and then you would be left with x plus 2. It's the same thing for both. Pull that greatest common factor out, x plus 2, and that leaves you with 2x squared plus 1 inside.